Uh, how do we change the velocity of an object? If I want to change the velocity of any object, then how can velocity be changed?
By putting force.
By putting force on it. When we apply force on the object, then its velocity changes. Either the velocity increases or decreases, that depends, right?
Yes, ma'am.
Okay. So in Newton's second law of motion, now here we are going to consider an object. Consider an object of mass m, and let's assume that at t is equal to 0, this object is moving with some initial velocity u, let's say. This is the initial velocity of the object. At t is equal to 0, when we had started observing the object, we saw that the object is moving and it is moving with velocity u. Now we had applied a force on the object. On the application of force, because we are applying force in the same direction in which the object is moving, so velocity will increase. So what if we apply the force in the opposite direction in which the object is moving? Then what happens? Velocity may decrease. So we can increase or decrease the velocity of the object by
By putting force.
application of force, right? Now the thing matters here is that in which direction we are applying force on the object. If we are applying force in the same direction which the object is moving, then velocity increases. While if we are
Increases.
applying force in the opposite direction in which the object is moving, then velocity decreases. In
Velocity
both the cases, there
decreases.
will be change in the velocity or speed of an object, right? In the previous class, we had talked about momentum. So what is momentum?
Momentum is like a product of an object that is that is
Like a
for velocity into
product
mass.
of an object's mass and
Momentum is mass
velocity.
into velocity. So if the object
Yes,
is of
ma'am.
mass
Yes.
m and it is, you can see it is moving with velocity u, then momentum is mu. And this is the initial momentum of the object. Initial momentum of the object is mu. Initial velocity and mass. We multiply these two to get initial momentum, right?
Hmm.
Now, on the application of force, the velocity of the object will change, right? Now its velocity is changed. It has become now v. Now the velocity is v. So again, you can see that there is change in momentum because velocity is changing, so momentum will also change. As momentum is the product of mass and velocity, we're keeping the mass fixed because we are talking about the same object which is moving, but velocity is changing. So now the velocity is m into v. This is the final momentum of the object and it is m into v, right?
Yes, ma'am.
So there is a change in momentum, you can see
Yes.
change in momentum. So what is the change in momentum here? How do we find change in momentum? We can write final momentum minus initial momentum as change in momentum. We subtract the momentum to find the change, no? है ना?
Yes, ma'am.
Yes, ma'am.
We subtract the momentum to find the change. So final momentum minus initial momentum is the change in momentum. So change in momentum is your final momentum is mv. So write mv, and then initial momentum is mu. Write mu. Take m common. In the bracket we have v minus u. So change in momentum is this m into v minus u, or we can write this as mass into change in velocity. You can write like this as well. All right, clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now, because see, we have applied force on it and there is a change in momentum that we can see in the object. And this change in momentum, what is the cause of this change? Who is responsible for this change? Which component, which quantity is responsible for this change in velocity or change in momentum?
When we put force to the
Force.
other side, the object is moving.
Yes. So Newton's second law of motion says that this change in momentum depends on force. So Newton's second law of motion, I'm writing here, right? The heading, second law. Newton's second law of motion states that the rate means speed or time na, in which the momentum is changing. The rate of change of momentum. The rate of change of momentum with time is directly proportional to the external force applied. The rate of change of momentum with time is directly proportional to the external force applied. Rate of change of momentum with time means change in momentum per unit time. Change in momentum divided by time is directly proportional to the external force applied. This is what Newton's second law of motion states. And this change takes place always in the direction of applied force. So in the
Done,
direction
ma'am.
which we are applying the force, the change will take place in the same direction which we are applying the force, right?
Yes, ma'am.
Yes.
Please write this in your notebook.
Done, ma'am.
So second law of motion we are talking about, right? So Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force. And this change takes place in the direction of force applied. In the direction which you are applying the force, the change takes place in that direction. So you can see what is happening here. Look at the video, this GIF.
The boy is kicking to the wall.
The boy is kicking to the wall. Is there something happening to the wall, or
And he got hurt on his
The
feet.
boy injured.
the boy got injured? Do you see any change in momentum here?
No, ma'am.
Okay, so
Uh,
how will you relate this with the physics and the concept that we are learning here?
he
Uh,
has put force on his leg to kick the ball, and he has got hurt in
Hmm.
his feet. That's why.
And in the second GIF, what do you observe?
That a boy is kicking the ball easily.
Kicking the ball. So it's
No.
easier to kick a ball. And the same
Yes.
force when he had applied on the wall, he got injured. While the on applying the same force on ball, he could, kick the ball quite easily. So what do we
Yes.
conclude? It's fun, right? So what do we conclude from this?
That the ball was hard to kick, and while the ball was much softer than the ball,
Mm-hmm. Yes.
and there was no,
Yes, please.
there was there was nothing to stop, like when he kicked the ball.
Nothing to stop, we can say that's
Yes.
correct, but you can see that the mass of the wall, or we can see the wall is quite rigid and hard, and
Yes, ma'am.
it is at its place,
yes.
right? And
Yes,
the
ma'am.
force applied to the wall is not sufficient enough to, break the wall. No?
Yes.
Yes, ma'am.
So, second law of motion states that there is a net external force acting on a body. It relates to the net external force and the acceleration of a body. So, acceleration is produced when force acts on a mass, right?
To cause an object to
Yes.
accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far because it has more mass than the little kid. So the more mass.
So what does this indicate? That if you want to accelerate an object, more acceleration is produced when you apply more force on it, on a given mass. If the mass is greater, then greater amount of force is needed. No?
Yes, ma'am.
If the mass is, if the object is heavy, then we need to apply greater force on the object to accelerate it.
Hmm.
And if the object is not very heavy, then we only a small amount of force can accelerate it. Acceleration is, what is
Acceleration when like
Uh,
putting
the
speed.
See, acceleration is rate of change of velocity with time. If there is a change in speed of an object with time, then we say that the object is accelerating. As you can see that we have accelerated in our cars as well. When we press the accelerator, then speed of the car increases.
Yes, ma'am.
And on releasing the accelerator, the speed of car decreases. So accelerator works like this, right? So acceleration is the
Yes.
term, it is the term in physics, and it means that if there is a change in velocity or if there is a change in decrease or increase in velocity, then we say that the object is accelerating. Object is accelerating means it is changing its velocity. It is not moving with uniform or constant velocity. Okay? So you
Yes,
have
ma'am.
seen two GIFs and number of things here. So we can relate, physics and the laws with the everything happening around us. No, so we unconsciously know the second law as well.
Hmm. Yes,
Everyone
ma'am.
knows that heavier objects require more force to move the same distance than lighter objects, right?
Yes.
Yes.
So what does this mean?
That if there is more mass, we need more energy to push it or pull it.
Yes. So Newton's second law gives us an exact relationship between force, mass, and acceleration. We can relate these three quantities using Newton's second law of motion. Means if the object is heavy and we want to accelerate it at the same rate, then we need to apply more force on it. And if the object is lighter, even a small amount of force can accelerate it properly, no, the way we want it to accelerate.
Yes.
So it talks about how fast an object moves. Mathematically, second law can be expressed as F is equal to ma, mass into acceleration. Force is mass into acceleration. Please write this.
We need to rejoin.
Okay, okay. And Newton's second law of motion is the most significant law among the laws of motion. And you'll get, so many numerical problems based on Newton's second law of motion. And we use this relation everywhere in mechanics. So, because you have seen that we had a formula, na, F is equal to ma, where we relate force, mass, and acceleration, right? So, Newton's second law of motion measures the quantity of force, it finds the force, whereas Newton's first law of motion describes the concept of force. When we talk about Newton's first law of motion, we say that whether the object will, क्या था? Newton's first law and every, बताओ,
What?
what was Newton's first law of motion?
Inertia. That tendency of object that if it is at rest, it will stay at rest. It needs force to we need force to move it. If it's in motion, it will stay in motion, and
Yes.
it
Unless
is
or until some external unbalanced force is applied on the object to change the
external.
state of motion, the object which is at rest stays at rest, and the one which is moving with uniform velocity or speed will continuously move with the same speed.
Yes, ma'am.
Right? So, Newton's first law of motion tells us about the nature of force, it tells us about the concept of force, it tells us about the definition of force, right?
Hmm.
Newton's first law of motion tells us about the definition, the concept of force, while Newton's second law
Yes,
tells us
ma'am.
about the measurement of force. And it says that force is mass into acceleration. So if you know the value of both mass and acceleration, you can find force by multiplying the quantities together, mass and acceleration, no? Because
Yes.
F is equal to ma on multiplication on the product gives you the force. So Newton's second law measures the quantity of force. It determines the quantity of force. It tells us about, gives us the mathematical relation about the force, no? While
Yes.
Newton's first law defines force. Newton's second law measures force. ठीक है?
Hmm.
So unit of force. In CGS system, unit of force is dyne. D-Y-N-E. Pritish, please turn on your camera. CGS system is centimeter gram second. CGS full form. The full form of CGS is centimeter gram second. In the CGS system definition, the unit of force is dyne. While in the MKS or SS system, unit of force is Newton. It is denoted by capital letter N. and 1 Newton is 10 raised to the power 5 dyne. So if you want to convert, see, as we convert centimeter in meter into centimeter or centimeter into meter, in the same way this conversion can be done. And you will study this conversion, about this conversion, that how do we get this 10 to the power 5 dyne in class 11. Okay? So as we have
Yes, ma'am.
1 meter equals to 100 centimeter, no? So both meter and centimeter are the units of length, no?
Yes.
Length, unit of length is meter in MKS system and unit of length is centimeter in CGS system. CGS is centimeter ग्राम सेकेंड. तो CGS सिस्टम में लेंथ की यूनिट होती है सेंटीमीटर, MKS सिस्टम में लेंथ की यूनिट होती है मीटर, and we can relate these two units, right? We know 1 meter is 100 centimeter.
Yes, ma'am.
In the same way, in CGS system, unit of force is dyne, while in MKS system, unit of force is Newton. And we can again relate these two units. 1 Newton is 10 raised to the power 5 dyne. Okay?
Yes.
Ma'am,
Hmm?
can I turn off my camera because I need to charge?
Okay. So can you define 1 Newton? See, when
1
force
Newton
is
is
said to be 1 Newton, force is
10
mass into acceleration. Force is mass into acceleration. So if force is 1 Newton, force is 1 Newton when both M and A are 1 and 1, no?
Yes.
1 multiplied by 1 gives you 1.
Hmm.
Right?
Yes, ma'am.
Because F is ma. So if m is equal to 1 kg and acceleration is 1 meter per second square, if mass is 1 kilogram and acceleration is 1 meter per second square, and because F is equal to ma, on putting these two values there in the force, in the formula of force, you will get the value of force. It is 1 kilogram meter per second square or 1 Newton. We write force as mass into acceleration, no?
Yes.
And
Yes.
we measure mass in kilogram, and we measure acceleration in meter per second square.
Hmm.
So collectively, we can write unit of force as kilogram meter per second square, no?
Yes, ma'am.
Because it carries the unit of both mass and acceleration. Because force is mass into acceleration, and unit of mass is kilogram, and that of acceleration is meter per second square, and therefore we can write unit of force as kilogram meter per second square. Also, because आपका जो unit है, unit of force is Newton in MKS system, it is Newton, right? So we say that Newton is, either we can write Newton or we can write kilogram meter per second square. They are the same thing, means the same thing.
Hmm.
Okay, now the question is, define 1 Newton. When force is said to be 1 Newton. See, if we have an object and that object is of mass 1 kilogram. Now we are applying force on the object, and by suppose we have applied force and this force is sufficient to accelerate the object by 1 meter per second square at the rate of 1 meter per second square. So this force is producing an acceleration of 1 meter per second square in the object of mass 1 kg. Then how do we write force? Because we write force as mass into acceleration. So on putting these values here, 1 kilogram and 1 meter per second square, we get 1 kilogram meter per second square as force. And because kilogram meter per second square Newton means the same thing, so we can write 1 Newton also. Clear?
Yes, ma'am.
Yes,
And
ma'am.
one more thing I want to add here
Yes, ma'am.
is you can see that here in this, because this is the unit of SI unit of force is Newton, and we also write kilogram meter per second square. So this is the MKS system where we have meter, kilogram and second system, and this is your centimeter, gram and second system. So kilogram becomes gram, meter becomes centimeter, and second stays as it is. And therefore, in CGS system, this unit is written gram centimeter per second square in CGS. Because in MKS we write kilogram meter per second square. In MKS we write
kilogram per second.
kilogram meter per second square. So in CGS it
Yes.
becomes gram centimeter per second square. Okay. Also, as we write Newton,
Yes, ma'am.
in SI system, in the same way we write dyne in CGS system. DYNE. Okay. I
Yes,
hope
ma'am.
this is clear.
Yes, ma'am.
Okay, so if a force produces an acceleration of 1 meter per second square on an object of mass 1 kilogram, then the force is called 1 Newton. This is the definition of 1 Newton. Dimensional formula of force is MLT minus 2. You will study about dimensional formula in higher classes. Here we write mass by M, distance by L, and time by T. And because you can see the unit, it's kilogram meter per second square. Kilogram is the unit of mass, no?
Yes, ma'am.
So we're writing M in place of
Yes,
kilogram
ma'am.
and L for meter, and this per second square we have here. So we're writing T minus 2 for time. Okay. We'll study about dimensional formula in detail in class 11.
Okay, ma'am.
Now let's take a few examples. Ramu's car, which weighs 1000 kg, is out of gas. Ramu is trying to push the car to a gas station and he makes the car to move with an acceleration of this 0.05 meter per second square. Using Newton's second law, you can compute how much force Ramu is applying on the car. Can you compute force using Newton's second law? Mass is given, acceleration is given. Can you find force using Newton's second law of motion? Mass of the car is
Yes, ma'am.
1000 kg.
Yes.
Acceleration produced is 0.05 meter per second square. Find force. Pritesh, you can turn on your camera now.
It's low battery. Like it's 4%.
Yes, please give me the answer.
Yes, ma'am. Doing.
I'm doing.
You've done.
Ma'am, force
No,
is
ma'am.
50 meter per second.
Please come again.
Force is 50 meter per second.
Unit is wrong.
Square.
See, force is
Square.
not measured in meter per second.
Meter.
That's the unit of velocity.
For
Ma'am
50 in
was
Newton.
getting
Newton.
50.
Yes.
15 Newton.
Yes. So we'll multiply mass and acceleration. The values are given to us. So you will get forces 50 Newton is the correct answer. Hello. Which of the following is the most significant law of motion given by Newton? Third law, second law, first law, law of gravitation.
Second law of
Law of
motion.
gravitation.
Second law of motion.
Second law.
Oh,
That's correct. Next question. A force produces an acceleration of 1 meter per second square on an object of mass 1 kg. The force is defined as 1 dyne,
1
1
Newton.
1 test.
1 Newton.
1 Newton.
Yes, that's correct. 1 Newton. If mass is 1 kg, acceleration is 1 meter per second square, then force is 1 Newton. We have question here on the screen. A body of mass 4 kg moves with a uniform velocity of 10 meter per second. What force acts on it? Why? Can you find this?
Body of mass, velocity. Yes, ma'am. We need to find mass. No, we
Mass
need
is
to find
given. Velocity
acceleration.
is given. It is 10 meter per second. What force acts on it? This velocity is uniform velocity. Uniform velocity means
That is moving in a constant speed.
so if the object is moving with constant velocity, will it accelerate?
No, ma'am.
So is there any acceleration produced in the object?
No, ma'am.
The acceleration is
0.
0. So how do we write force? We write force as mass into acceleration.
Yes.
Mass is 4,
Yes, ma'am.
4 kg, acceleration is 0, so force is 0.
Force is 0.
0 Newton. So if the object is
Force.
moving with constant velocity, we need to justify na why. So if the object is moving with constant velocity, there is no change in velocity, right? So
Yes, ma'am.
no force is applied on the object in that case. So you can relate this with Newton's first law of motion. Newton's first law of motion, which states that an object at rest stays at rest. An object which is moving with uniform velocity will continually move with the same velocity in the same straight line unless or until some external unbalanced force acts on the object. जब तक किसी ऑब्जेक्ट के ऊपर एक्सटर्नल अनबैलेंस्ड फोर्स नहीं लगेगा तो जो रेस्ट पे है वो रेस्ट पे रहेगा और जो मूव कर रहा है वो कांस्टेंट वेलोसिटी से मूव करता रहेगा. तो अनबैलेंस्ड फोर्स नहीं लग रहा इसलिए ये कांस्टेंट वेलोसिटी से मूव कर रहा है, hence it is not accelerating, hence force is 0. Okay,
Yes,
Yes,
ma'am.
ma'am.
please write this.
Okay.
Please read the question first.
A 2 Newton force acts on a 2 kg body. Calculate the acceleration produced.
You can do this.
So we need to find the acceleration.
First write the quantities which are given to you. Force is given, mass is given.
2 Newton. Mass is
You
2
have to find
kg.
acceleration.
Acceleration 2 into
As F is equal to ma, this implies A is equal to F by m, because you can see that m is multiplied by A. Na? So when you'll move your m to the other side, divide it, now put the values.
Yes, ma'am, it's 1.
It's
Acceleration
what
is
is
1.
the unit? What is the unit of acceleration?
Newton.
Ma'am, meter per second.
Meter per second square.
Where?
And you can also write Newton per kg. If you find something, something written like this, Newton per kg, that's the unit of acceleration as well, because we are dividing force by mass with mass and to get acceleration, no?
Yes, ma'am.
Written? Yes. Find the force required to give a 0.2 kg body an acceleration of 3 meter per second square. Mass is given. Acceleration is given. Always write the quantities which are given to you first, and then write the quantities which you have to find out, and then formula. Now put the values and get the answer.
Ma'am, 0.6 Newton.
0.6 Newton. Can I write kilogram meter per second square? Is this correct? If I write like this?
No, ma'am.
See, this is also correct. You can write kilogram meter per second square as well, because F is equal to ma, right? So we can write the unit of mass and acceleration together. So your Newton is kilogram meter per second square actually. Okay, so we can write like this. You can write this
Yes, ma'am.
2.6 Newton. This is the answer. Clear?
Yes.
The velocity of a body at rest changes to 8 meter per second in 4 seconds. So body is initially at rest. है ना?
Ma'am, acceleration is 1.
In 4 seconds, the velocity of
Sorry,
the
mass is 1
Ma'am,
kilogram.
8 meter per second. You're getting acceleration as
Mass is 1 kilogram.
Okay, mass is 1 kilogram. Force is 8 Newton, no? This is given to us.
Yes, ma'am.
The initial
Yes, ma'am.
velocity and this is the final velocity. So first we'll find acceleration. Mass is given. Mass we have to find out.
Yes, ma'am.
Yes.
Mass will
We need to
not
find
be-
acceleration first because acceleration is not given, but initial and final velocities are given. So what is acceleration?
Like this
It's 1.
8 meter second minus 1.
See, that is not acceleration. That's your final velocity. Read the question properly. The velocity of a body at rest. So initially the body is at initially the object is at rest, body at rest. So initially the object is at rest. So initial velocity is 0. The speed changes from 0 to 8 meter per second in 4 seconds. So velocity is changing from 0 to 8 in 4 seconds. When a force of 8 Newton acts on the object. So force is given, it is 8 Newton. Find the mass of the body. Mass we have to find out, but acceleration is not given. You have written acceleration as 8 meter per second square, which is wrong. Unit of acceleration is meter per second square. तो ये तो वैसे भी नहीं है. It is in meter per second, no?
Yes, ma'am.
So we cannot write this as acceleration. So we need to find acceleration first. And how do we find acceleration? What is the formula for acceleration? We had
Formula for acceleration.
How do we find it?
M into F. M divided by F.
So to MA we had done in Newton's second law of motion. But before this, in the chapter motion, we had done this formula of acceleration.
Force upon mass.
That we are doing now. But the previous chapter, we had talked about acceleration. So acceleration is rate of change of velocity with time. No? What is acceleration?
Rate of change of momentum.
Velocity.
Velocity.
So it is V minus U by T. Acceleration is final velocity minus
V
velocity
by T.
upon time. How do we find acceleration?
V minus U by T.
V minus U upon T.
What is V?
Velocity.
Final or initial?
Initial.
Final.
Initial is पहले वाली, final is बाद वाली.
Yes,
Yes,
ma'am.
ma'am.
Final and U is initial. Now put the values 8 minus 0 upon time is given 4. So this is 8 upon 4, 2 meter per second square. This is your acceleration. Now find mass. For mass, we'll write the formula F is equal to ma. Now, because F is equal to ma, this implies m is F upon a. Force is 8 Newton. Acceleration is 2 meter per second square. And hence, mass is
4.
4 kilogram.
4 kilogram.
4 kilogram is.
Can we write 4 Newton meter per
No, this is
square
mass,
inch?
not force. No, we are getting the value of mass.
Oh, yes.
For force, we can write Newton. For mass, we will write kg.
Yes, ma'am.
Clear? Please revise your
Yes, ma'am.
concepts that we had done in the previous classes. We had talked about, in motion chapter, we had done velocity, displacement, acceleration, uniform and non-uniform acceleration, equations of motion we had done, graphs we have done. No?
Yes, ma'am.
Revise that chapter as well because all these chapters are linked to each other. When you will do gravitation, you will do the same equations of motion that you had done in chapter motion. Okay?
Yes, ma'am.
Yes, ma'am.
Anything you want to ask? Any doubt?
No, ma'am.
Okay, so I'm going to end the meeting now.